Hi everyone, the channel Easy Lecture welcomes you. In our previous video, we were discussing about voltage to current conversion using operational amplifier. In that video, we discussed what are the requirements, what are the needs to do that kind of conversion from voltage to current, and what is meant by voltage, what is meant by current. So all those things we discussed. We compared voltage and current with the flow of water. We compared flow of electrons with flow of water, and we analyze a lot of things related with voltage and current. In this video, we are going to discuss about current to voltage converter, the reverse process of the previous video. So before entering into the video, subscribe my channel Easy Lecture. Now we shall go for further discussion. So here, current to voltage converter. So what is the need to do this kind of conversion, current to voltage conversion? Under certain conditions, we may use certain sensors, and that sensors converts. So usually the sensor, they convert physical parameter into electrical signal, and if the electrical signal to which that physical parameter is converted be in the form of voltage, in the form of current instead of voltage, but using that physical parameter, the device which are needed to be operated using that physical parameter is controlled by voltage. So under this circumstance, we need the current which is produced by the sensor to be converted into voltage. Only that particular electronic device can be operated. For example, let us take a photodiode and a motor, a DC motor. The photodiode, it converts the light signal into electrical signal, the intensity of light. Let us consider an example of a solar tracker. Okay. And this photodiode, it is a photosensor device, and there are a lot of photosensor devices like a photoresistor, phototransistor, and photodiode. This photodiode, what does it do? It converts that intensity of light into the equivalent electrical signal, and the electrical signal is in the form of current and not in the form of voltage. Okay, but the motor which is being operated by this light intensity requires voltage to get operated. Okay, and here we need to convert that current into voltage. Only then the motor can be operated. So under this circumstance, we need this current to voltage conversion, right? So whatever the circumstance may be, wherever we need the voltage for operating the device, but we have the source in the form of current, then this circuit is applicable. Now let us go to the circuit diagram. So this is the basic circuit diagram which converts current into voltage using operational amplifier. Here in the input side, we are giving the current source instead of voltage, and also we are giving the input in the inverting terminal, whereas in voltage to current conversion we gave the input to non-inverting terminal. Here non-inverting terminal in this circuit is grounded, and the output we are getting from the 6th pin. There is a feedback resistor here in the negative feedback path, right? And we know that always the current also produces voltage. So what is meant by voltage? In our previous video, we said voltage is a form of force that drives the electrons to flow in a particular direction. So ultimately, whenever the flow is there will be some force. Okay, for example, let us compare this again to the flow of water. Okay, so we are using some mechanical force to make the water to move from one place to another. To enhance the flow of water, we give some force, some mechanical force. Using a motor, we pump. Okay, let it be. So during the flow of water, if we dip our hand inside water, when it is flowing, our hand may feel some kind of force. So ultimately, we can conclude that the flow of water, it is generating some kind of force. It is giving some kind of force. If we dip a wheel in water, in flowing water, the wheel rotates. That means it is rotated by the force generated by the flow of water. So whenever a flow is there, ultimately we can generate force. So this is the thing. Here also we can compare this. We can compare this again to the flow of electrons. When the flow of electrons are there, force is generated, electromotive force is generated. So when current is there, voltage will be there. Current is there, voltage is there, right? So this is the thing. So here in the output we are having voltage, and there is a current flowing in the feedback path. this current after reaching this node, it may go in this direction and also in this direction. But since in this direction operational amplifier is there and the input impedance of operational amplifier is very high, the current cannot enter in this direction. So whatever the current that is flowing in the feedback path, it enters into the input path. So no current enters into the operational amplifier. So we can conclude that I is equal to, so the feedback path, the current in the feedback path is I, that is equal to the current in the input path I equal to IP. Now we are going to apply Kirchoff's current law at this node, and we are going to replace it for I. So how can we write I at this node applying Kirchoff's current law? So here the current is flowing in this direction from this point to this point, and in between we have RF. So I can be written as V0 minus VA divided by RF. So that is what we have written, V0 minus VA divided by RF. So that is equal to IP. Since we know that I is equal to IP, I is nothing but V0 minus VA divided by RF. Now again, the value of VA. What is VA? VA equal to, VA is the voltage at this node, and that point is virtually grounded with respect to non-inverting terminal of operational amplifier. The non-inverting terminal of operational amplifier is connected to the ground, so ultimately VA, the value of VA is equal to 0. And the concept of virtual ground I have discussed already in inverting amplifier and non-inverting amplifier, and substituting the value of VA here, we'll be getting the equation as V0 divided by RF equal to 0, which is V0 equal to IP into RF. Okay, that means IP equal to V0 divided by RF. So from this equation, V0 is equal to IP into RF, we can conclude that the output voltage generated in this circuit, produced in this circuit, is directly proportional to the current that is given in the input side. So we can say that this is current driven voltage source, and the voltage can be given to any device which is being operated by voltage, not by current. Okay, so this is how this circuit works. So here, since the voltage that is produced, since the output produced, it is in the form of voltage, and it is equivalent of the current which is given in the input side. An equivalent value of voltage is produced for the input current. Okay, so voltage is directly proportional to the output voltage is directly proportional to input current. Okay, so we can conclude that this is how we convert current to voltage, and this is current to voltage converter. Okay, so we shall analyze this using an example. As I mentioned already, here we are using photodiode. So an ordinary PN junction diode, it requires some kind of force, some kind of the potential difference, okay, the EMF, to make the electrons to cross the junction to ensure the flow of electrons in PN junction diode. Whereas in photodiode, we do not require any electromotive force, just the intensity of light that is falling on the photodiode is sufficient to charge the electrons. The electrons gain energy from the photons, from light. It gets charged, it gets energy, and the charged electrons, they tend to move, and when they cross the junction, they produce current, and that current is given as the input to the current to voltage converter circuit, and in the output we are getting the voltage. Okay, and the intensity of light, the equivalent voltage that is produced by the intensity of light, can be viewed by connecting a CRO here. To CRO we need to give voltage as the input, but this photosensing device, photodiode, it is generating current, and the current is given to current to voltage converter. That generator voltage is given to CRO, and CRO will produce the equivalent voltage value for the intensity of light that is falling on the photodiode. So this is where we need current to voltage conversion. This is why we perform current to voltage conversion. Thank you for watching this video. If you like this video, kindly comment, like, share, and don't forget to subscribe the channel Easy Lecture. Meet you again in another video. Bye.